Hello and welcome back to my YouTube channel. Today we are going to see State Board Class 10 Science 1 Chapter number 4 Effects of Electric Current. In that already first two parts already we have completed, and in that we had already studied about the heating effect of the electric current, and after that we studied about the magnetic effect of electric current. We had already studied about the left hand rule to find out the direction of a magnetic field produced around the conductor, and after that we had already studied about the Fleming's left hand rule, in which we studied about the using left hand and the mutual perpendicular two fingers and the thumb, and if we place two of them in the direction of given directions, then the third one gives automatically. After that we are going to talk about the electric motor, one of the most important appliance which we are using nowadays. Instead of appliance, calling it will be machine will be much better. This machine, when we talk about the electric motor, is useful in various appliances which we are using, like fans, refrigerators, mixers, washing machines, computers, pumps. Means wherever we need rotations, whenever we require the rotation of one of the device or the one of the part of the appliance, then we are using electric motor, and we are going to see the working of this. First of all, we will see the basic concept of the electric motor, what exactly we have inside it. So when we talk about the electric motor, the most important part what we have is the strong magnetic poles, north pole and south pole. In between that, these two strong magnets, we have a coil. Here this is a coil we are having, and it's attached with the split rings. You can see here split rings. Why it's called as a split ring? Because there is a gap between hemispheres, or the or the semicircles. Calling it semicircle will be much better, because it is a half rings from both the sides and it completes the circle. If you will observe in it, there is a gap in between, and that's why it's called as a split ring, and the two ends of the coil is connected to each individual rings, and this particular is connected, like here we are having connected to the power supply. Now we will go towards the working of it. This was the structure of this particular electric motor, and we will go towards the deeper part of it. We have an axle in between the, this is called as a axle. Why it is called as a axle? Because when we talk about this particular, arrangement in this, when the coil starts to rotate inside, then this axle plays a axis role for the rotation. That's why it's called as an axle. Now further is, when the power supply is on, current starts to flow through it, and when it reaches over here, it goes in the coil this way, and then from here it comes this side, and you can see there is a change in a direction. This was going upward and this is coming downward. So two opposite directions we have. When two opposite directions are there, due to the magnetic field produced in the coil and the strong magnets present, they are also having their magnetic field, two magnetic fields, then this starts to repel each other, and this goes upward and this goes downward. So this produces a torque between the coil's arms, arm AB and arm CD. So that torque, when we talk about, when this goes up and this goes down, it starts to rotate. So this is a cycle of the electric motor we have, and this split ring plays very important role, because what happened when this rotates and comes over here, direction remains the same. Direction of electric current remains the same. It's not changing, because CD, when it will rotate and come over here, CD, then direction will be upward, not downward. Means the torque which is produced in it remains in the same direction. It's not changing. And due to that, it goes on rotating continuously. It goes on rotating continuously. It's not changing its direction. And further part, when we talk about this complete working they have given, the next what we have to discuss is a electromagnetic induction. Electromagnetic induction is nothing but the phenomena of electric and magnetic field combination, where when we have a two coil, suppose the best example I am taking over here is, suppose if there is two coils, one coil is over here and another coil is here. These two coils are in a vicinity. If I want to draw it a more clear picture, then you can see over here the one coil and the another coil is on this side. This two coil, this if I am calling as a primary coil and the secondary coil, and power is supplied across this, battery is used over here, then the current starts to flow in this. Once the current starts to flow, this will produce a magnetic field around itself, and this magnetic field will pass over to the second coil. And if we change current continuously, the magnetic field strength changes continuously. And if there is a change in the magnetic field continuously, then there will be a current in this. It will produce a current in this. It will induce a current. Instead of using a word produce, inducing will be the proper word for it. It induces the current in the secondary coil. And this particular phenomena is called as a electromagnetic induction. Electro, then the magnetic, and then induction. EMI, electromagnetic induction. When the electricity is supplied, magnetic field gets generated, and this produced magnetic field induces a current in the secondary coil. So this is nothing but the phenomena called as the electromagnetic induction. This electromagnetic induction is very useful in various devices, like one of the sensitive device which we call as a galvanometer. Galvanometer is a device which works on this particular phenomena, and galvanometer is a device which is used to find out the direction of the electric current in the electrical circuit. Further, when we talk about the working of the galvanometer, it's a simple concept. Is generally when we talk about the electric meters, they have the reading at the end. Starting from 0, it goes up to let's 10, and it's divided further like this. But in a galvanometer, we have the scale where 0 is at the center. If the pointer moves this side, then the left side we have a direction of the electric current, or if it moves on the other direction, then the direction of current gets reversed. Means two directions on the meter scale of the galvanometer shows the two direction in the electrical circuit, direction of the electrical current in the circuit, from which end to the which end electrical current is moving. Further, the next, when we talk about another topic, what we have to discuss in this is Faraday's law of induction. Faraday's law of induction, which gives the concept of the motion of the conductor. Because when we talk about the induced current, magnetic field, and the motion of conductor, because if there is a motion of conductor, means there will be a change in a magnetic field continuously, and then the middle finger of the right hand will give us a direction of the induced current. The Faraday's law of induction is that Fleming's right hand rule. Like in a previous part, we have said about the Fleming's left hand rule, where the two fingers and the thumb, if we will keep them stretched outward and mutually perpendicular, same way in a right hand, if we place two fingers, the index finger and the middle finger, and the one thumb stretched outwards in such a way that they are mutually perpendicular, then this also helps in to understand the concept of the electromagnetic induction, or it gives a direction of the various things. So what we are supposed to do, we have to place the middle finger in the direction of the induced current, and then the index finger in the direction of the magnetic field, then the thumb will give us a motion of a conductor, and the thumb will give us a motion of the conductor. Further, next what we have to study is the alternating current and the direct current. Alternating current and the direct current is nothing but the concept of the two types of the power sources. When we talk about the alternating current is nothing but the current which we are getting at home. At home, the electrical supply or the electricity supply what we are having is nothing but the alternating current. And if you will draw the graph, and if you draw the graph for the electric current and the time, we will get a sine wave. This we call as a sine wave. And you can see here the amplitude is changing: positive, negative, positive, negative, positive, negative, and so on it will go on. And that's why it is called as a alternate current or the alternative current. Whereas when we talk about the direct current, the batteries which we are using, the cells which we are using at home in the remote controls of television, refrigerators, then the in remote controls of the air conditioners, means wherever the remotes are used, they all are using the power in a DC format, or the in a DC form, which we call as a direct current. Now in the direct current we have a stable current. It's not an alternate current like a alternating current in the AC signals. We have a straight line graph for it. You can see over here we have a straight line graph for the stable DC, increasing DC, stable DC, and reducing DC. And that's why the name is given to it as a direct current. Now here they have given the cycle changes 1 upon 50 seconds for the alternating current which we are getting at home, and that's why the frequency is called as the 50 hertz. And if you have observed all the appliances, there the frequency is written as a 50 hertz, and even in the electrical points which we are using at home, on that also it's written as a 50 hertz. After that, the next what we have to study is a electric generator. Till here we studied about the electric motor, how it is working, means the electrical energy we were converting into a mechanical energy. Now here the next what we have to study is the electrical generator or the electric generator, in which the mechanical energy is getting converted into a electrical energy. Now in this particular section, when we talk about the picture, you can see it is almost same as the previous one, electric motor. The differences are what? Let's see the differences. Here we are using a galvanometer, or the current meter we can use to find out the total how much current is getting produced. Instead of a split rings, we are using over here is a slip rings. We are using a slip rings instead of the split rings. Now here what happened, what is the meaning of this? In this particular section, when we talk about the slip rings are nothing but where the coil can continue with the same ring. The complete rings are there, 2 rings, and the coil which is connected on it is completing a 1 cycle. So in this what happened, the current what we have in the arms like arm AB and arm CD remains the same, or the direction remains the same. And due to that, what happened, the direction of torque which is produced in the coil is changing continuously after each half cycle. And due to that, what happened, it rotates like this, it rotates like this, means both the side. So this is nothing but what the alternating current, where the direction changes continuously. So the concept of that alternating current is, I think, clear why that particular direction of current is changing continuously. It's because of this complete rings what we are using, because here the current connections are permanent, or the coil connections are permanent, and due to that, when the coil rotates, the direction of a torque changes continuously, and that's why the we are getting as a alternating current generator. In the DC generator, only the differences in a DC generator, I'm just giving you a hint, is the omitted section of this here. DC generator, what we are having, only the difference in the DC generator is this portion. Here, instead of using a slip rings, we are using a split rings, and due to that, what happened, it breaks continuously, and the same direction we are getting in the DC generator. So this is about the chapter effects of electric current.